All right, we are going over the Unit 5 math practice worksheet. Number 1, how much energy is required just to boil 200 grams of H2O? Okay, so let's just check in with this other helpful chart that you've got. So let's say this chart is for water. Right now it's generic, it could be for any substance, but as soon as we add in the specific melting point, which is 0 degrees Celsius for water, and the boiling point, 100 degrees Celsius, now this diagram is for water. So the question is, how much energy does it take to go from this point to this point? So the equation that we use can't be Q equals MCAT, because that involves a change in temperature. We're not changing temperature, we're changing phase. We're going from a liquid to a gas. It takes a lot of energy to do that because water molecules love each other so much. So the equation is Q equals delta H vaporization times moles. Now, don't let this scare you. It's just a constant. And scientists have figured out the amount of energy it takes to boil 1 mole of a substance, in this case water. So it takes 40,700 joules to boil 1 mole. Well, how much do we have? We've got 200 grams of H2O. We've got to figure out how many moles that is. 1 mole of H2O weighs 18.02 grams. So we've definitely got more than a mole because we have more than 18. Multiply across the top, divide by the bottom. This comes out to be 11.1 moles. So if it takes 40,700 joules to boil one mole, how much does it take to boil 11 moles? Multiply and I get 451,770 joules. Number 2, how much energy does it take to then heat that 200 grams of H2O from its gas phase at 100 degrees to 125? So if we go back and look at this chart, now we're here. Oops, I didn't want it to do that. Now we are here at this point. Okay, I'll do a star now. And we're going up to 125. So we need this equation that involves a change in temperature. So Q equals MCAT, and we're in a gas phase, so I'm going to put C with a little g. So the mass is 200 grams times the specific heat for water in the gas phase, and it's listed right up conveniently here at the top. 1.86 joules to heat 1 gram 1 degree Celsius. So we're figuring out how much energy it takes to heat 200 grams by 25 degrees Celsius. So to get this 25, I just subtracted 100 from the 125. You'll see grams will cancel out, degrees Celsius will cancel out, and now you're left with your energy units, joules. That's a good thing. I get 9,300 joules. Now number 3 says, how much does it take to go from liquid water at 100 degrees all the way up to steam at 125? So going back to this chart again, all it's saying here is, I'm going to take all this away, is what if I hadn't split up the problem and it said go from here to that 125 degrees? So conveniently for us, all we have to do is add up our answers from 1 and 2. So the 451,770 plus 9,300, answer 461,070 joules. Number 4, what if it doesn't split it up for you? We got to go from negative 15 degrees Celsius to liquid water at 0 degrees Celsius. So let's go back to our chart. We're starting at minus 15. So right here would be minus 15. I'm going to put a star there. And we're going to liquid water at 0 degrees. So the second star. Because right here, this is 0 degrees solid. And by the time it gets to this star right here, it's all turned into a liquid. So we're going to need two equations. One to go from -15 to 0, heating that solid up, and another one to go from 0 degrees Celsius solid to 0 degrees Celsius liquid. Okay, so let's do it like this. -15 degrees up to 0 degrees Celsius, we're going to use Q equals MCAT, and the specific heat will be for a solid. And then we're going to go from 0 degrees Celsius solid to 0 degrees Celsius liquid. And so we're going to use Q fusion, because that's what we use for melting, delta H fusion times moles. Alright, so how much energy does it take to get up this first little curve? Well, the mass is 5 grams. The specific heat for a solid for H2O is 2.06 joules per gram degrees Celsius. And to get up this first little slope, we're changing the temperature by 15 degrees. That multiplies to 154.5 joules. Okay, we're not done yet though. Delta H fusion is listed at the top in your little table there. It's 6,010 joules per mole. Uh-oh, a little extra work here. 5 grams of H2O, how many moles is that? Well, it's not even going to be a whole mole, because 1 mole weighs 18.02 grams. You only have 5 grams. So this comes out to be 0.28 moles. So now we do 6,010 times 0.28 moles, and that is equal to 1,837.3 joules. So now what I need to do is add these two numbers together to get that total answer. And that comes out to be, oh, oops, I see what I did here. I was looking at the wrong thing on my cheat sheet. This was 1,682.8. And then when you add those two together, you get your final answer, 1837.3 joules. So I'm going to box that, because there's a lot of stuff going on here. Oops, trying to make my J better too. Alright, try and be neater in the next one. Number 5, genius level. Not really, more like annoying. Okay, because we got to get 40 grams of ice all the way from -25 to 138. That means we're going to need all of the equations here. Oops, I don't know what happened. Okay, you get the point. We're going to need all the equations. Okay, so we're going to go from -25 to 0 degrees Celsius. Then we're going to go from 0 degrees Celsius solid to 0 degrees Celsius liquid. Then we got to go from 0 up to 100. Then we got to go from 100 degrees liquid to 100 degrees gas. And then we got to go from 100 to 138. Oh my goodness. Okay, so for this first one, it's a change in temperature. And it's a solid, right? If it's below 0, it's frozen. Then we're going to melt. Q fusion equals delta H fusion times moles. Then we're going to heat again. Q equals MCl delta T, because it's a liquid when it's between those temperatures. And then we're going to boil. QVAP equals delta HVAP times moles. I'm running out of space. And this problem's too big. Q equals mCg for a gas, delta T. Alright, let's start plugging numbers in. Okay, so for this first one, mass is 40 grams. Specific heat for a solid, you get that from your green sheet, or it's right at the top of this, 2.06. And this first change in temperature is 25. So that multiplies to be 2,060 joules. 1/5 done. Delta H fusion for water is 6,010 joules per mole. I'm doing a bad job with my units. And we've got 40 grams of H2O. We got to get this into moles. So 1 mole of H2O is 18.02 grams. Hopefully you've got that memorized now. So we're talking about 2.2 moles here. So multiply by 2.2 moles. And just for the melting phase change, it's going to take 13,222 joules. Now this middle step, the mass is still 40 grams. That doesn't change the whole time. Specific heat for liquid, 4.18. Temperature change, 100. Multiply all of those, 16,720 joules. Delta HVAP for water, 40,700 times, we already figured out the moles, 2.2 moles. That multiplies to 89,540 joules just to boil that much water. And then our last one here, 40 times the specific heat for water in the gas phase is 1.86 times the temperature change 38. That's 2,827.2 joules. Then I need to add all of my circled numbers except the moles. That was just, we were using that. It adds up to be 124,369.2 joules. So that is the final answer. That's as hard as it gets and as annoying as it gets. Alright, number 6. Which one would have the higher boiling point? The more the molecules like each other, the harder they'll be to boil. Alright, this is taking us back. NH3, is it polar? It's pulling, that nitrogen is pulling up, up, and up, and it does have a hydrogen bonded to an F, an O, or an N, so this one has hydrogen bonding forces. Those are the strongest. HBr, the Br is pulling, so it is polar, but it's not superpolar. That one has dipole-dipole forces, so not as strong. So the one that would be harder to boil would be NH3. For the second one, nitrogen and another nitrogen, that's a tie. So that's the weakest force. That's nonpolar. So dispersion. And H2O, that's really strong polar bonds. And it does have an H bonded to an F, an O, or an N. So it's got hydrogen bonding. So water would be much more difficult to boil. Makes sense. Nitrogen's already a gas. That's what you're breathing in. Letter C, we got to draw it. C2H2. But carbons and hydrogens are a tie. Nothing's winning. So that's nonpolar, and that would have dispersion forces. HCl, if you look at your electronegativity chart, the Cl is winning. Partial negative, partial positive. Get a bunch of these guys together, they're going to attract each other, but not hydrogen bonding, not that strongly, but it's got the middle forces, dipole, dipole. So that one would have a higher boiling point. All right.